So we're coming to you from the Roar Room here at Penn State. We're here today to talk to you about pathways to STEM at Penn State and what STEM means. I'm Dr. Travis Masterson. I'm an assistant professor in the nutrition department here at Penn State, and I'm here with a couple of my colleagues.
Yeah, I'm John Coupland. I'm a professor in food science in the College of Agriculture. And Yvette?
Yeah, and I'm Yvette Richardson, and I'm the Senior Associate Dean for Undergraduate Education for the College of Earth and Mineral Sciences, and a professor in the Department of Meteorology and Atmospheric Science.
Mm-hmm.
So I think we're from different departments, and so STEM might mean kind of different things to each of us, right?
Mm-hmm.
Mm-hmm. Mm-hmm.
I think it's really interesting because we've got a college in this university called the College of Science. We've got a college called the College of Engineering, and none of us are from those colleges.
Right.
But there's many programs within our colleges that consider themselves to be STEM programs. And I think it's the integration of the letters is really interesting.
Yeah. And those letters are science, technology, engineering, and mathematics, right?
Yeah.
Mm-hmm.
Mm-hmm.
So there are like those colleges and programs set up like specifically for each of those letters, but then all of our disciplines kind of pull from them, right?
Yeah, I mean, in Earth Mineral Sciences, we have some social science, we have a lot of physical science majors, and we have 5 engineering majors. They're just not in the College of Engineering, they're in the College of Earth and Mineral Sciences. So, yeah, there are hidden gems around the university where you can do really interesting STEM work without being in one of the other colleges.
Yeah, and I think all of our programs have like the technical definition of STEM. It's like a designation here at Penn State. And I think the purpose of that is to make sure the students that are interested in those fields can get to those fields. And it also helps, like at least in the case of our department, we have a lot of students because we're in the College of Health and Human Development. So we have nutrition, kinesiology, biobehavioral health. One of the main things that we're looking at doing is trying to get students into health professions. So we have a lot of students that are looking at doing physician's assistant school, dentistry, medical school, those types of things. So that STEM designation is very important for our students to be able to go into those fields as they move forward in their career paths.
Yeah, and we have these great STEM majors that, kind of integrate the fundamental sciences. So students who are interested in chemistry and math and physics, might want to do meteorology, which is in our college, or one of our engineering programs, around energy or materials. So there's kind of the core. You can be a physics major, you can be a chemistry major, biology major, but we have majors that then sort of draw from those core disciplines into other specific disciplines like meteorology or geosciences or energy engineering, for example.
Yeah, I think I really like that you picked on the word integrate there, because I think that's something that's perhaps different in our colleges. I'm in the College of Agriculture, and I'm going to talk more about food science because that's what I know most about. That's where I spend my time. And it's not like a discipline of food science. It's almost like there's a set of problems that need to be solved. We're really interested in manufacturing foods in factories, industrial scale, making sure it's nutritious, making sure it's safe, that kind of thing. But it's not like that's a problem which is solved with chemistry or biology. It's the bringing these things together and focusing on problems. And I think you could say the same things for other kinds of ag programs where it might be an environmental problem people need to concern with. It might be plants or animals, that kind of stuff. And it's drawing from the sciences, drawing from engineering. I like STEM, not because it's like here's science, here's technology, here's engineering and math. It's here's STEM. Here's all of these things kind of blundering together. And I think that's where you get the power of these maybe more applied programs that we're involved with.
That's a good word, is applied, right? I think a lot of students coming out of high school, your high school courses are very like you're taking physics, you're taking calculus, they're very like siloed. And there are programs like that here, which is not a bad thing too. Like if you want to be strictly in that discipline, but then we have like these applied problems like you're talking about, right? Where you're taking some of those courses and then you're applying them to specific problems in a specific field, right?
Yeah.
So it's more like the applied version, because we do a lot of chemistry, physics, those types of things, but it's applied to the human body specifically and around food. Same thing with like kinesiology, for example. They're doing a lot of physics and biomechanics, which is applied to a specific outcome, right?
Sure.
Yeah.
I bet there's tons of social stuff in your world as well, like social sciences and working with people, and maybe in the EMS as well.
We have some. Yes, in our geography department. Geography is very broad. It has both social science and physical science. So some people study real human-centered problems, and some are studying things like how do patterns of land use affect wildfires.
Yeah.
So there's just a wide range of problems that are really like societally relevant that can be studied.
Yeah. And that's what, like my lab, for example, we study eating behavior, which is a part psychology, part understanding like the environment that you're around. We've collaborated with people from geography before, obviously food science. And so yeah, there's like, it's like a good mixture of all of these things that are relevant, right? To like actual human problems and conditions. But that's a good note too. And I think we see that in food science and probably in your college as well, is like there's probably sub-disciplines within any college, right? So like in nutrition, if you were really interested in chemistry, there's a lot of biochemistry going on, and there's faculty that specialize in that. If you're more interested in the psychology, there's faculty like myself that we kind of specialize in that side of things. If you're more interested in policy, that's available too, right? And so you can get that applied kind of science in a field that you're interested in. So for example, like if you're interested in the human body and how it functions and works, then, like nutrition is great. If you're interested in food or geography or geology or whatever it might be, right? Yeah.
I can't leave the field you might be interested in without jumping in as an agriculturalist at this point, because we have a lot of fields in our but and aside from just the sort of academic study of human beings and psychology and sociology, there is just like a sort of place-based aspect to this, that it's not like an isolated test tube or an isolated laboratory. Very often the problems we're trying to solve happen in specific places. I have colleagues who are interested in like row crops, and it's a farmer that's growing them in their field. And the scientist in my college might be a really good plant scientist interested in plant pathogens, but really needs to find ways of working with individual farmers, getting out in their fields. And just because you've come up with something which might be the best chemistry or biology to address this problem, if it doesn't work in the field, and it might be just real practicalities of how you move this stuff around in a muddy field. I like that. I think it really sort of anchors a lot of programs, certainly in my college, and I'd love to hear about yours, to real people trying to solve real problems. It's not. It is an academic subject, but that sort of sense of academic as being kind of distant, it's hard to maintain in agriculture. Yeah.
Yeah, we have students who have loved the weather since they were little. Often they loved it since they were little, and they come to study meteorology. And a lot of our disciplines have a real focus on that, on like helping people, right? You want to be a meteorologist because you want to provide better forecasts and like contribute to society that way. Or you want to be a energy engineer because you like to provide a stable energy grid for society, right? And so I think that's a really great thing about being in a STEM discipline. You're figuring out how the world works, right? That's kind of what makes science so cool. Like you're finding new discoveries. You're at the cutting edge of what we know about things. And that's just super exciting to be part of. But then you're also trying to, then how do we use that knowledge to actually like help society and work toward, better sustainability, sustainable development goals, things like that.
Yeah. And I think just with that, the disciplines that we have are also nice, because if you just want to go to that bachelor's degree level, I think all of our fields have good jobs that can be entered at that point. But then also because that's because the science that we do is so applied, right? That you can take students and get them into something relevant like immediately that is going to be contributing to society or business or whatever it might be, right? But then there's also the opportunity to pivot in a lot of cases. So that's where things like if you wanted to get deep into the science, our disciplines probably set students up well for graduate school, for pursuing a PhD, those types of things. But then also, like I mentioned, we also, because we're in STEM fields, it also allows students to pivot out into medicine or dentistry or whatever it might be, which are also advanced degrees. But I think students benefit quite a bit from getting to see the applied side, right? So a lot of people that go to med school, for example, they start with biology because they have to take a lot of the hard like chemistry and bio courses as prerequisites. And again, that's not a bad pathway. But then we also have a lot of students that come to nutrition. They get all the physiology, they get all the chemistry that they need as part of our program. But then they also have the unique aspect of like understanding kind of like the human condition more broadly and some of the other things that are going on instead of just the nitty-gritty physiology side of it, right? And that's very valuable as they apply to med schools and different things like that because they're looking for in those applications, for example, people that stand out. And I think that it also makes them better doctors, or physician's assistants or whatever it might be as they move on because they have a slightly more holistic view of the human condition rather than just the very mechanistic view. And so I think not only is it valued by those advanced programs, but it also just gives you an edge outside of the application itself.
I'm interested with both of you, how your students kind of get into solving real practical problems while they're still students. I know many students have come into college and getting the A's is the most important thing and passing all the courses. And I'm not going to diminish that. I'm a professor. But I think all of us we value doing things with knowledge. And maybe our programs have some common features in there.
Yeah. We have a program called the EMS Academy for Global Experience, which tries to really create community around students trying to have all these experiences beyond the classroom.
Sure.
So many of them will do research with faculty. I mean, that's why you come to a research university. Some students anyway, right? Because they want to be part of that really cutting-edge research. So we try to facilitate that in all different ways. We have some really terrific facilities too. Like we have really tremendous material science labs. And so our students get to be part of that and work in those labs. And there are some fellowships offered to do that with especially the Materials Research Institute and other places. So, our students apply to research experience for undergraduates at other places as well, or sometimes they get to go on field projects. Like one of our students went out on a field project looking at hail and, driving around, intercepting storms, looking at hail formation, collecting hail, measuring it, all of that.
Storm chasing.
Yeah. Well, that's actually what I do for a living. Yeah.
Oh, wow.
But, that is my research, tornadoes.
So like Twister is like your actual life.
Yes, right. Tone down. Yeah, that's right. But I think it's so important for students to have those experiences, right? Like, it just makes them understand the material and appreciate it in a different way than in lecture.
Yeah. We also similarly have internships built into our core curriculum, and that can take a lot of different shapes, whether you're going to like a hospital to be in a clinical setting, or if you're doing research with a professor. Those opportunities give you a chance to kind of see a lot of different things. So a lot of students that come to my lab for research opportunities, they're often interested in like the med school kind of pathway. And so it's actually very nice because we have a pretty strong collaboration with the College of Medicine, the campus here at University Park. And so in my lab, we have 2 to 4 med students working on projects with us that are integrated into patient care itself and working over with the students there. And so a lot of our undergrads get to go interact with the med students. They get to meet some of the professors over at the med school, the deans. They kind of get to interact and kind of see that environment ahead of time. And some of them have even been invited to come like do a couple days as like a med student and sit in on classes, those types of things. And so like those are kinds of experiences that you, really I don't think you can get elsewhere unless you're like involved in these kind of STEM fields that are applied, that let you like build those connections and have those opportunities, and it's built into the coursework, right? It's not like an extra thing you have to do just to pad your application for grad school or whatever it might be. It's part of like what you're getting to do here.
I think these are so important, and we commonly talk about like it's really important to get involved in research labs. And I've had students say to me like, I don't want to be a researcher. I want a proper job.
Well, internships are great too.
Exactly. But the thing with doing things like research experiences or internships is you're trying to actually do something with your science. It's not just absorbing it. It's like, now let's make this work. Now let's actually go into a field and try and catch hail. Do you do that? Anyway, whatever it might be. But you're trying to do that. There's a student I was talking to just the other day who's studying how sourdough works, like all the different microorganisms interact. And maybe she'll be a sourdough person for the rest of her life. But even if she hasn't, the fact she's worked closely with a leading researcher, she's learned the disciplines of working in a lab, she's presented her data clearly, she's owned that project. That takes you to a place that getting an A doesn't get you to. It's
I was just going to say, I think those internship opportunities too. So, for example, I had to do an internship as part of my undergraduate education. And my internship, I thought it was the direction that I wanted to go with my career, right? And then I did my internship and realized this is not for me.
Right? That's such valuable information now.
Yeah, because it saves you a lifetime of going down the wrong path. I'm sure it would have worked out fine, but it did open my eyes. But I also had the opportunity to get involved in research, which I had never considered. But the opportunity kind of presented itself, and then I got sucked into that. And I think that's that's a big thing of like having these different opportunities. You might come into college with a preconceived notion of where you might be going, but a lot of times you don't know what you don't know until you kind of get some experience. Like you might not know certain fields even exist, or that certain jobs are even available or relevant or anything like that, right? And so like being able to like look at the different STEM fields, not just the hardcore disciplines, but others that are attached to STEM, looking at different colleges, and then taking advantage of some of those experiences and going down that route can really help guide you, or like at least let you kind of experience like what it might be, give you some insight into what you might do. But then also having so many options available to you, like at Penn State, allows you to pivot. If you don't like something, there's going to be something here that does appeal to you at some point, right?
Right. We always say this is a time of life to try different things, and then you're trying it for a limited time. So if you don't like it, that's really valuable. You can change your path and go down a different route and see if you like that. And this is the time to be doing all of that.
I'm pretty sure I'd be interested if we could compare notes across our programs. If you came in the first semester at Penn State and you did like a course in calc, maybe intro chem, maybe a biology course, I'm willing to bet there'd be a lot of majors in each of our college would be, okay, because you've done that, it's an easy transfer. That you took a gen ed and discovered that kinesiology is like, why didn't I not know? Nobody tell me about this? And you can make those moves.
Change a major?
To change,
Oh, yeah.
As long as you get those basic chems and maths.
Right.
Yeah.
If you start on a STEM path, it's very easy to switch around within STEM. A little harder if you start outside, but it can still be done.
Yeah.
It just might take longer.
And I'd say that was my personal experience, not here at Penn State, but at my university where I did my undergraduate work, I came in as like a business major. And then it wasn't until later then I was like, oh, I'm really interested in health. And I was actually in kinesiology originally, and now I'm in nutrition. And so it took me a while to figure that out. But I was able to, use those science courses that I was taking as my generals and kind of like the backbone of some of these programs. They're kind of guiding you and filling in those science courses that you need. And then it's really looking at the application, like where are you going to apply this? Are you going to apply this in exercise? Are you going to apply this in nutrition? Are you going to apply it in food science? So I would agree that it does that. And I think that a lot of students might come in with a preconceived notion of like, I have to know what I'm going to do at the end of these 4 years, and I have to be locked into my career choice. But I think more often than not, it's probably a little bit more flexible than students first.
Definitely.
And I mean, you don't obviously want to bounce around forever.
Right.
But there is those first couple of years where you can kind of...
At the beginning, right.
Yeah.
Yeah, I agree. I want to pick up on one thing you said about like the importance of, what students get out of doing research with a professor. And I think one thing they really get from that is just understanding where our understanding comes from.
Yes.
Right? Understanding that it's built on lots of research done before and a whole foundation of what other people did. And now you're trying to just move that a little bit farther.
Yeah.
And that's something you don't necessarily get, in your class. But coming away with that and then deciding, do you want to be part of that? Do you want to go to grad school to do research later? Because you want to be part of that ever advancing of knowledge is a really great thing to figure out when you're an undergrad.
It's astonishingly empowering.
Yeah.
I remember moving from like doing like science in high school. You learn stuff and you pass exams and stuff like that. Then as an undergrad, getting into a lab, and it's such an obscure measurement I was making. But all of a sudden it's like, oh yeah, I can, now I've measured that number. Now I know something different about the world. It's not, it's a tiny thing. It's nothing that anyone's ever going to care about. But that's a powerful sense.
Yes.
And it's the capacity to discover and evaluate knowledge is so human.
Yeah.
I mean, I teach food chemistry classes, and I'd love people to believe that knowing this chemical reaction is something they've got to carry for the rest of their lives. It's not, but it's a powerful framework to start to fit other knowledges into it. But the experience of getting into a lab, and it doesn't have to be a chemistry lab, there's all sorts of means by which STEM fields generate and evaluate knowledge. But it's powerful if you can get into it.
Simulations.
All of this stuff,
Yeah, and I'd say even just some of your coursework can accomplish that too. So like a lot of what we end up talking about in our courses beyond like the chemistry and the equations that you need to know, those kinds of things. But I always try and tell my students like understanding the science is really important, because in my field, we deal with a lot of misinformation on like social media and people's like this, that, and that. So telling our students, like, if you understand the underlying process that's going on here, if somebody is like for real or not. If that makes sense, right? Like, if they're just making something up, because they'll say, oh, well, and it's absorbed this way, or it's gonna do this in your body, but you could say, well, that's not really how that system works, right?
Thinking, right?
Right. And so sometimes we have students that are like, why can't I just, say this food or that food or just make things up? And it's like, well, yeah, you have to kind of understand the science, and when you do, that science really opens up your eyes to like what's going on kind of in the normal world almost. Like, oh, how would somebody know that? Like, how would they understand that? Or they must not understand this system because they're saying this thing, right? And it kind of opens your eyes up a little bit too to what's going on.
Right. I was wondering, maybe we could talk about like where our students end up. Like, so one thing that's great about STEM, I think, is that I think you said this earlier, it opens so many different pathways. Like you could go into industry and the private sector and, start your own business and create things. Or you could go to grad school to do research like in a government lab, or do research in industry or something. Or or like some of our students become broadcasters on TV for weather, or they become forecasters in the Weather Service. So there's just such a broad range of what's possible. It's impossible to really even articulate all the different ways that students can use the STEM degree.
Mm-hmm. I'm thinking of something Travis said earlier about how the bachelor's degree is like very often a useful thing in its own right. It's not like you have to do the bachelor's before you can do a PhD and then you can do something.
Right.
I think certainly the fields in ag, most of the fields have like a pathway for a bachelor's degree to get you somewhere where you are valued for your technical skills.
Right.
And it's some of it's going to be in a lab. Some of it's literally going to be in a field doing crop evaluations, that kind of things. But there's all sorts of ways where having that kind of technical knowledge makes you valuable. Sales is a weirdly important field. I used to think sales was just being like sharp-tongued and communication stuff. But very often, someone who's good in technical sales knows their technical field really well. So they can go and talk to a farmer or a crop or an animal care facility and say, okay, this is your problem. This is how we can solve the problem. You need this product of ours will solve it. But there are other ways of approaching it, and you're kind of bringing your expertise to a place, and that's a useful thing to do. So you're counting on your technical skills, your technical competence, but using it in a very human way. I have to say the salespeople always make more money than anyone else as well.
That could be.
Yeah.
Yeah.
But there certainly are loads and loads of places. And I think another thing we've been kind of playing around a lot with this is just the diversity of things. It's not just one or two places. There's a program in my college around golf course management and turf grass.
Yeah.
And I was... I had no idea what turf grass was. I don't do that kind of thing. But if you have these qualifications in how grass grows for sporting events, it's super valued.
Oh, yeah.
And not many people have it. It's kind of niche-y, but if you're in that niche, it's a really good niche to be in.
Yeah, definitely.
Yeah.
Definitely.
Right, and that's like one of the things I think that's important to realize too. I think it's easy to come into a field and just say, well, this is the direction to go, and people kind of look at that like, oh, I just want to be a finance guy, or in our field, one of our main directions is dietetics, right? And so a lot of students start out on the dietetics track, but then what they come to learn by the end of it all is that there's a lot of more options than they might think. So I always try and tell my students that you're really building a skill set that can be applied in a lot of places. And so you should really be building those skills and looking for those opportunities because, maybe you didn't know about turf grass, but you have some scientific background and that opportunity presents itself. And you never know what that might be, and you might need to be ready to pivot. Like in my example, my life, I was in exercise science kinesiology, but a really great opportunity came up in nutrition, and I was able to make that pivot because the science is the background is very similar, right? And so you don't have to go in being like, this is the thing that I'm going to do, but as you start down a STEM pathway, like I think we've said this several times, it allows you to do that. But not just in terms of like what degree do you end up with, but also like what job opportunities are out there and what you might do with it. And maybe it is good to go down that very direct path of like, okay, I'm going to do sensory science in the food science department, and I'm going to end up at a food company and help with their teams. And that might be the pathway you start down, but eventually you might see a pivot where there's other opportunities that open themselves up.
You really don't know what life is offering you. You might even ending up doing a podcast or something like that.
That's right. You never know. You never know.
Yeah.
I started as a physics major. Well, I ended as my bachelor's in physics as well. I had never even thought about the weather as something people studied. Honestly, it was pre-internet then, so it was harder to find careers, right? And I just saw a poster one day for a summer institute on atmospheric science and applied to it, went to it, and switched to that for grad school. So I always tell students, too, to be open to those kinds of opportunities because if I hadn't seen that poster that one day and applied, there's almost no chance I would be a meteorologist now.
Yeah.
I would probably have gone to grad school in physics and done something different, but I'm really happy that, I stopped and looked at it and applied, and it changed the whole course of my career. And that happens with our students too. They just have to, be looking for opportunities that come up.
Yeah, we've had a lot of students pivot just because they've gotten involved in research or different things like that. But I think that's also another good thing about Penn State broadly is it's good to get involved in things. There's going to be different clubs, different events and opportunities that come around, and so it's good to be in a university where there's a lot going on. It can be overwhelming a little bit, but if there's something that catches your eye and you're like, well, I've thought about that, but I've never seen it. There's always something going on or somebody you can talk to that can give you some insight into that world. And so maybe you check it out and it ends up not being your thing, or maybe it ends up being your pivot, but that's a big advantage to being in a place like Penn State.
So much to offer.
Yeah. On top of that, everybody here is the top of their field.
Yeah,
so if you're
exactly.
interacting with somebody, they definitely are giving you the best information possible.
Yeah.
I wonder sometimes if Penn State is not doing itself any favors by our college structure when we talk about these kind of things. That how you end up finding out about these types of things. So if I was applying to Penn State and it was here's the College of Agricultural Sciences, I don't want to work on a farm. I don't know anything about farms. I've never set foot on a farm. And all of a sudden I've given up on these other things if nobody had sat down and explained turf grass or another program to me, I wouldn't know about. Or earth and mineral sciences.
We have 5 engineering degrees.
Yeah.
But you wouldn't know it from the name.
Yeah.
Right. So maybe even just prospective students,
true.
even just taking a minute to look through not just the college names, but potentially the majors within that college. That can be a good place to start, right? I didn't know exercise science was really a thing till I sat down with my course catalog or my major catalog and looked through some of this stuff, right? So we were kind of talking about how there are a lot of colleges, there's a lot of majors, there's a lot of different disciplines, sub-disciplines, all these kinds of things. So it can be kind of confusing navigating that when you're first coming in. Like I said, I had to look over a course catalog and read through everything. Does Penn State provide any resources to help with some of that?
Yeah, I think they have a Find Your Fit tool that can be used where you can specify different interest areas that you have and then kind of narrow down to get majors that would fit with those interests. So that I think could be really useful for seeing engineering across the whole university or
so if you put in engineering,
or,
it's not just the School of Engineering, but all the potential engineering degrees or all the pre-med degrees or okay.
I wasn't aware of that because it strikes me as there are a few students who just come in at 18 with this bright-eyed sense that I want to be a chemist or I want to be a golf course superintendent. And good for them. I mean, it's but I think most of the time it's a vague sense of what you think you can do. And what you value. I mean, for some students, the economics of getting a job at the end is really critical. And this is an expensive place to be. And getting the job is an important thing. For many students, I like working with people. For many students, science was always my favorite subject. And I'm really glad to hear there is a pathway that you can sort of start from sort of where you are and where you want to get to, rather than saying, okay, now I must drive in for this particular major, or college.
And I think that some of that's driven also just by again, you don't know what you don't know. You don't know what's available to you until you're there. I had come in as a business major because that's what my parents had told me. I didn't know what else is there, and I don't think they really particularly did either, right? Because they only know their experience from when they were at college, or if they didn't go to college, they might not know what's there at all, right? And so I think having tools like that could be very beneficial to help you kind of see the broad scope of what's available to you.
Right. a lot of students are interested in the environment, right?
Yeah.
And that is in both of our colleges.
Sure.
Different ways
There isn't
to
a
look at
college of
that.
environment.
Right,
Yeah.
right. So having a tool that can help them see how you can study that in different majors across the
Yeah.
university, I think is really important.
I think DUS is also just a wonderful resource. And I didn't get my degrees in the US where this wasn't a thing. But for students to be able to meet with an advisor who isn't in a college and can sort of know something about what that student wants, that can be a really good, effective pathway forward. And if your first semester is scheduled with sort of generically useful STEM courses,
Yeah.
that could be a good pathway
can go
in for many
anywhere.
students. Yeah.
I think also students, if they're not sure, taking some of the great gen ed courses that we all offer,
Yeah.
to get a taste of a STEM discipline
Yeah.
that you might be interested in. It's going to count toward your general education anyway, but that can be a really good way to discover some of these other majors.
Yeah. Well, and that also talks to like the other campuses that Penn State has. A lot of those programs are set up to get through those gen eds in the not here at University Park, right? But they provide basically the same courses. I know, like in our department, for example, a lot of the same courses are taught at these other campuses, and then when students transfer over, it's super easy to bring them into to our current program for them to finish out their last couple of years,
Right.
and that is an extremely valuable way for students to get from maybe not wanting to come straight into University Park to be able to move over easily, right?
Yeah.
Oh, yeah, absolutely. I mean, we all have suggested academic plans that lay out how you do the 4 years if you start at a campus, right?
Yeah.
So we've thought this through about how to make that as seamless as possible. We've been collaborating with engineering on a program called Multi-Campus REU that brings students from the Commonwealth campuses to University Park for the summer to do research with someone here. So it really helps with kind of catching up on the research side too, so that when they come here in the fall of their junior year, they're like already engaged with a faculty member. And,
and actually,
in the community.
So between nutrition and food science, we have an REEU program as well that we bring students in from Commonwealth campuses as well as other universities. They come in for the summer, and the whole point is to get them to see what research is like over the summer and kind of see the crosses between food science and nutrition, for example. Yeah.
And that can, and I said Penn State is an expensive place, but that can reduce the costs and make this place more accessible.
By being at the Commonwealth campus.
Exactly,
Yeah, exactly.
And also, I think that's true, too, of like you mentioned the integrated undergraduate degrees, which is where you essentially can get a master's degree within 5 years. So it's a slightly accelerated program, which is another way to effectively get further into the science portion of things, or get to those advanced degrees where it saves you a year of like money essentially, right? But then I also think a lot of programs have a discounted rate for that fifth year. It's still at the undergraduate rate instead of the graduate rate. And so there's a lot of good programs in the sciences to help people get through to those advanced degrees faster and cheaper. If that's something that you know coming in, like I want to pursue that. So speaking of like research in STEM fields, I think that there's so much you can do, and you can actually do quite a bit as an undergraduate, more than I think a lot of people think. So I've actually had several students in my lab, and even a student here. I did my graduate work here at Penn State, and I had an undergraduate working with me there as well, and they've actually published papers. So like they're the lead author of the paper, and that paper gets published in a major journal in our field, right? And, we've had other students that have just participated and been there, but we had a really great student in our lab, and she had started out on like the dietetics track, kind of like what we were talking about. Like that's a very direct field to apply the skills and requires doesn't require like a PhD at the end or anything like that. But she had started volunteering as a researcher in our lab. And was just excellent. And so she ended up running her own project where she was looking at how food marketing on social media was affecting how people were interacting in chat rooms. It was a big project where she basically got to take the lead and had to look at messages and pull a bunch of data. And so she got a lot of skills in like, how do you analyze what's going on social media? So beyond the nutrition portion of it, she got a lot of like technical skills of like, how would somebody do that kind of a thing, right? And then, she worked with me. It wasn't like she was just off on her own doing it, but we took her through the steps on like, how do you write a paper and how do you get it to a level where it's possible to publish it in an actual journal, not just on like a blog post or something like that, where it's going to make some impact, right? And going through that experience, she realized at the end of it all, not only was she a published researcher at that point, but she realized she really wanted to be in research. And so she pivoted from dietetics to doing her graduate degree. And then she was set up to basically get into any program that she wanted because she had a first author publication as an undergraduate, right?
That's huge.
Do you guys have had students that were successful in your programs?
Yeah. I had a student who started working with my colleague and I in his first year, and then just continued. He did an IUG, so an integrated undergrad-grad program where you can do all of it in 5 years, but he did it all in 4. Just really a wonderful student, and then got his PhD 3 years later. So like 7 years out of high school, he had his PhD.
Wow.
Just a really tremendous student. But yeah, similarly, just really discovered that research was his thing and was just read everything, ran simulations, went out in the field with us, did everything. And now has a great career. Yeah.
It's often a hurdle for many students to take that step.
Yeah.
Because when you have like the requirements of a program, it's take this course this semester, take this course this semester, and you're on the track. But in order to get into some of these other experiences, you've got to like respond to an email. You've got to go and like knock on a professor's door who you don't know.
Yeah.
And that's a hurdle.
Yeah.
And I can only encourage students to try. But you can't do it for them. Because it tends to be a much more sort of personal, almost not quite apprenticeship, but that very close mentoring relationship, but that you're looking for. But the student has to take the step. Has to say, I'm interested in doing this. And sometimes the professor's not going to be interested, and you're going to walk away and maybe feel low for a couple of days.
Yeah. We've tried to put in some structures to help with that in some of our departments. In geography, they have a program where graduate students can basically undergrads work for the graduate students who, of course, are mentored by the faculty. Sure. And so they're part of the whole group that's working on research. But there's a nice structure to it to help with overcoming those barriers to getting involved.
That's good to hear.
Yeah, but I would second, like, if anybody listening to this podcast, for example, like a lot of students, they think it's harder than it really is. Like,
yes, you don't have to be a genius to do these things.
Yeah, no.
Some of the success in these places is showing up, being organized, doing what you say you're going to do. It's not. We're not looking for Einstein to be in these programs.
Yeah. No, I definitely say I'm never the smartest guy in the room for sure. But yeah, I think a lot of students come and they think they have to like provide something but really, like a lot of professors, what they're really just looking for is somebody that's interested in what they're interested in, right? It's just like one of the easiest things you can do is you can just Google your professor and see what they published. And if you wrote to a professor and said, hey, I read your paper on XYZ, social media, whatever, I thought it was cool, that professor would be like, hey, great, you should come volunteer in the lab. I think, especially here at Penn State, I think a lot of the faculty are very friendly, very collaborative. I think sometimes, again, because we're a lot of us are in the top of our field, it can seem intimidating to the students, but we're just normal people.
I've had
We
students talk about sort of, I couldn't go and talk to this professor because I've only taken one course in this field. But we know that in order to be successful, even if you've taken all the courses in the field, I'm going to teach you something so specific about coding social media or finding something about hailstones or something like that, that you're not going to learn in your courses anyway. But if you are interested, I think interested should be like the number one academic virtue.
Yeah.
Never let this be beaten out of you. Just like, ooh, that's interesting is the best words to hear from a scientist.
Yeah.
And showing up is just huge.
Yeah.
If you say you're going to be somewhere, you will be there. Or you'll send an apology note in advance. It's not like anyone's trying to make an inhuman demand on you.
Right.
But if you start ghosting people, then you send a message.
I will say one skill that can be very helpful for students if they want to get into research is having some coding ability.
Sure.
Because that can really help, especially in a lot of the data-heavy fields like we have in earth mineral sciences. Being able to work with the data, being able to write a computer program or at least follow a computer program can be really, really helpful. So that would be my biggest advice if you want to get involved in research in a lot of our fields.
Yeah, I think one of the biggest missteps I see from students that maybe don't have as successful of an experience trying to get into research or get to know professors is the kind of like broad email. So we get, I don't know if this happens for you guys, but we get a lot of students they'll send an email. I'm trying to get into med school and I need 100 hours of research for my application. Could I work with you? And that actually shows like that you're not interested.
Right.
Like,
Yes.
do you know what I mean? It's obvious this was mass
It's a means to
email.
an end.
And it's like, oh, okay, so you're not really wanting to be here or really interested.
Right.
And again, it doesn't have to be like you're interested in that this is going to be your end goal, like that you're going to research what I research, but just that you're generally interested in this space. Like, oh, I'm interested in eating behavior kind of broadly would be, what I would be looking for. Yeah, whether you're going to be a social media researcher as like you move forward, like that doesn't matter so much to me, but that you're interested in the topic. Because I have a lot of students that start in my lab, they do a really great job and then end up pursuing different research directions than I ever would have. They come to me for advice. Do you think I should go to this program or this program? They pick the one that I wouldn't have picked, but it's because it's interesting to them. So again, it's just showing kind of just general interests and taking a little bit more of an initiative than just saying
curiosity about the topic.
Yeah, exactly. And taking a little bit of interest in maybe the professor's line of research a little bit more than just that broad, like, well, I need 80 hours for my application. It's like, oh, okay. All right. Cool. Well, I think we've covered a lot of ground today. So I just want to thank you guys for being here. And
it's been a pleasure.
Been fun. Thank you.